This is Rajesh Mishra, roll number 27, and I'm here to present an experiment on Science Corner. My experiment is to show how the light travels. So in order to perform this experiment, we need 3 equal size cardboard paper, a hole at the center, and the cardboard should be aligned in a straight line, followed by the candle on the other side. Now, how to perform this experiment? As you can see, all the 3 card papers are aligned and there is a hole at the center, and at the corner I have placed a burning candle. Now what we can see through this experiment is when all the 3 card papers are aligned and they are placed properly in the center, you can see the light travels through all these 3 holes and it forms in a straight line. So as you can see, the burning candle is clearly visible to us. Now as we move one of it, card paper, it can be easily seen. Now the light is not traveling through it. What does this mean? This means that light travels in a straight line, and as one card paper is moved, now you can't see the light visible to us. So this experiment proves that light travels in a straight line. Now again, as I am placing my card paper on the same alignment, again it is visible for us. See, the light of the candle will be visible to us. With the experiment number 2 now. Experiment number 2 denotes the different kind of lever that is required. In order to perform this experiment, you need a scale, a pen and a rubber. In this particular experiment, my rubber will be load, my pen will be called as a fulcrum, and the finger that I'll be placing will be called as an effort. So since this scale has been placed at the center, and you can find the fulcrum which is placed just below it. Now look at this load. This rubber is called as a load. As we place this load at the one corner, we see the scale getting diverted towards the verse side, inclined towards the other side. Now what we have to do is we have to apply an effort in order to make sure that the load gets risen up. Now how can we do that? When we place the load very next or very near to the center, we'll see the more amount of effort is required in order to raise the load. As we keep on increasing the distance, amazing result has been obtained. That is, the amount of effort that is required to raise this load is less. As we keep on increasing the distance, you can see the amount of effort which is required to raise this load. When I place my effort which is near to the center, it is too much. I require more effort to raise this load. But as I keep on increasing the distance, you can see the amount of effort which is required in order to raise the load is getting reduced. So this particular experiment is called as lever of first order. As we had performed the experiment for the lever of first and second order, now let's move ahead for the lever of third order. So the apparatus which is required for lever of third order is a tongue and a ball. Now how does this experiment works? As we know, ball in this particular experiment is a load. Tongue in this particular experiment is called as fulcrum. Now the effort that is required in order to lift this ball with the help of this tongue, as you can see, the effort that is required in order to lift the ball with the help of this tongue is more when we keep this effort closer to the tongue. As soon as we keep on increasing the distance, you will find the effort goes on increasing. The moment we keep our effort closer to this tongue or near to this load, you can see the effort is less. But as soon as we keep on increasing the distance, the amount of effort required increases. So this is what is called as third order of lever. Now let's start with the experiment number 3. In order to perform experiment number 3, the apparatus that we require is a glass, water bottle, spoon, packet of Eno and a matchstick. So let us begin. First we need to pour water in both the glasses. As you can see, I have poured water in both the glasses. Now the second step that we need to perform is we need to add Eno to one of the glass. So I would choose glass number 2 to add the Eno in it. Now what happened when I add Eno to it? Hold on, I need to read it. As we see what has happened in this. So Eno is a mixture of citric acid, sodium bicarbonate and sodium carbonate. So Eno is a pack which contains citric acid and which remains dry. Now what happens when Eno is mixed with water? The reaction produces carbon dioxide and an ample amount. So let us see how can we denote that the reaction produced carbon dioxide. So there is another packet of Eno. Let me just add it once more and then I'll show you how the reaction takes place. So now I have a matchstick. As you can see, I have burned this matchstick, placed well here. Nothing is happening to the matchstick. It's still burning. But as soon as I take this matchstick to this part, as you can see, the fire is